Actually, your lecture is very informative and you did a very nice work and you patented very good amount of things as well as you commercialized. It is very informative. And I have two questions. Actually, one question is when you are talking about antimicrobial studies and the active so did more studies or only you tried in vitro? And if in the case you tried in vivo study, how much effectively that sunlight you are using, how much effectively it will kill the bacteria?
Yeah, like we have studied in the lab. So most of the studies were carried out in the lab and like in vitro. And also when you use the sunlight,
yes,
it's a slow reaction. It's not a very fast reaction. So the results I have shown is under 6 hours of reaction.
Okay.
For example, what I should say is that when somebody, for example, if it's on a door handle, so if somebody with infection touches the door handle, and the bacteria will remain there, and the reactive oxidation species will start reacting it. But it's a slow process. If some person comes after 10 seconds and then touches that will contaminate. Okay, so it's a kind of additional processing or additional route to clean. For example, ceramic tiles or other similar material or glass materials. So it takes time. It's a slow process, but it's an additional protocol to remove the bacteria. You need to have like the same. So go on, please.
Yeah, can I ask? Actually, so bacteria which is present on the surface, not in the human. For example, actually, some people get a infection, like a bacterial infection. So you cannot treat with your photocatalyst, right?
No, absolutely not. This is only for the surface. You cannot use it for internal application. Absolutely not.
Yeah, and the second question, this one actually whatever you discussed about photocatalysis and glass cleaning. Actually, this one I wonder when you are keeping the glass inside our like a bathroom. So how our we can coat the thin film of that photocatalysis. How that thin film can absorb the sunlight, how it will be catalyze the reaction, how it can clean the glass.
No, sunlight, you don't need. You don't need sunlight in the bathroom. In the bathroom, you have your normal light.
Yes.
And the normal light also have a UV component there. So whatever light we use, it has a UV component. Typically around 3 to 4% the UV light is there, yes. And that is sufficient. And if you use a visible light active TiO2, and it can be more effective as well. The answer is even with the UV component in your bathroom light, it can be activated.
Okay. Thank you, Dr. Suresh. Really very informative. Thank you very much. Thank you very much. Yeah.
Sir, one more question is in the chat box.
You can I'll check that. Is there any possibility that formed it's from Abin in photocatalysis? Is there any possibility that the formed highly reactive?
Okay. Can I ask directly?
Yeah, please.
Okay. Myself, Abim, I am a PhD student in Tokyo Metropolitan University. So my question is in the photocatalysis area forms a highly reactive species like superoxide and hydroxide radical anions. Is it possible to react itself to the photocatalyst, thus degrading or decreasing the activity of the photocatalyst?
No, because this is a semiconductor material.
Okay.
So reaction species usually react with organic components of the, for example, tetracycline or any complex organic molecules or different types of dye molecules, bacteria, pollutants. It can work with any type of organic molecules, but it doesn't react towards any kind of inorganic particles or material.
Okay.
It will, but like a TiO2 is used for chromium reduction or arsenic reduction and all.
Okay. Thank you. And one more question regarding the usually the nanomaterial chemistry when we study like particle size can affect the band gap of the material. is a similar is also in the case of TiO2 also we can tune the band gap using the
Yeah, absolutely. You can tune the band gap using particles, particularly the quantum dots. If you develop quantum dots, you can that will impact the band gap of the titanium dioxide. The answer is yes. Yeah.
Okay. Thank you very much for the informative session. Thank you.
Thank you, Abhinay.
Hello, sir. Uni, sir. Hello.
Yeah.
Sir.
This is the ideal platform for the students to ask questions, learn. Therefore, we appreciate MSc students, scholars, etc., to float more and more questions. I have one question, Dr. Suresh. No?
Yes. Yeah.
Some days back, I read something about hybrid photocatalytic systems generating synergism. So instead of using only one type of a catalyst, a secondary, another transmission oxide is being employed, so that they generate a mutually complementary effect, a synergism type effect. Now, what are did your group work in the area, or what are your views on that?
Yeah, absolutely. That's a very important question. So the question is that is there any other materials, any other semiconductor materials we can use to improve the photocatalytic efficiency? So we can use heterostructures. For example, another semiconductor with a similar band structure can be used for this type of reactions. For example, zinc oxide can be used, or C3N4, graphitic carbon nitride, MOS2. So different types of heterostructures can be used to improve the properties. And also some of these materials are used to trap the electrons as well. So if you have a kind of lower band structure, the electron can jump into the heterostructure formed by the next semiconductor. So it can be used to improve the photocatalytic efficiency. And also some photocatalysts can act as a kind of trap, and in some cases it can use to improve the photocatalytic or the charge transfer processes, and thereby improve the photocatalytic efficiency.
Great. If time permits, I have one more question, which is supplementary.
Please, absolutely.
It is supplementary to what Dr. Chinnasamy asked, because you have an extension to the field. All this catalysis technology is being extended to the field. So how do you address? Because he asked a question regarding the sunlight within a bathroom. So, so when you make tiles, etc., for an ambience in Sligo, how do you ensure that such technology will work in Abu Dhabi also? Abu Dhabi, the room temperature is very high, and in Quebec, Canada, where often temperature is going to the minus level. So how do, when at different locations, how do you ensure the consistency in technology?
Yeah, absolutely. It's a very, very important and relevant question. And thank you for asking that. I think a lot of people have this question. Photocatalysis is like a temperature has an effect, but it is not a significant effect on the photocatalytic process. Okay, so it doesn't really impact the temperature in Sligo or temperature in Abu Dhabi. Okay, so that may have some kind of minimal effect. The other question is the light. Obviously, we have like less light here and more light in Abu Dhabi or Dubai. But this is a technology which works based on the wavelength of the light, not much on the intensity. Intensity has an impact as well, but it works based on the wavelength, because the radiation happens based on the wavelength. The intensity has an impact, but mostly on the wavelength. So the wavelength, as long as the wavelength is same, the reaction continues.
Okay, thank you.
Did I answer your question?
Yeah. Thank you very much. And please have more questions, please.
Yeah. Hi, Suresh. Yeah, it was a
Hi.
Yeah, it was a very inspiring talk from your side, and I'm very happy to see your very good results and the entrepreneurship. Okay, congratulations. Yeah, I just have one doubt. you are talking about the antimicrobial. So it is mainly antibacterial, right? Yeah. And what about the antiviral activity?
Like I haven't tested any antiviral activity yet, but there are a number of recent results on antiviral activity of photocatalytic materials. Even there are tests on like using these photocatalytic materials for against coronavirus.
Oh,
But
yeah, that's what.
I don't have, like, we haven't done that. We haven't done any type of viral testing in our lab.
Yeah, okay. Because currently it's a trend,
It is.
coatings for acting against COVID-19.
Correct. Yeah. Yeah. Absolutely. There are a number of reports on that.
Yeah, yeah. So have you done any attempt in that way?
You need to get permissions, different types of permissions, and like you have to have like controlled lab conditions. So we haven't got that yet. So in future, maybe, yeah.
Yeah, okay, yeah. Thanks, Suresh. Okay, thanks.
Okay, thanks, Ania.
All the best. Thank you.
Okay, thank you. Same to you.
Yeah, thanks.
Research scholars, MSc students, please. So, Dr. Sujit, if you do not have
Yes.
questions,
Yes, sir. We are not. We are taking Suresh sir's time also.
It's okay. Yeah.
okay, okay.
Sir, actually, it was an inspiring talk, because actually you started from very basics of nanotechnology, and your research also, it was very interesting. Sir, I think now I think we can conclude the session, sir.
Yeah.
Because okay.
Yeah.
Thank you, Dr. Sujit.
Okay. Thank you very much, sir. Thank you very much for your time for us. Thank you, sir.
Thank you.
And so we shall conclude this session with the permission of HOD on behalf of the department, NIT Calicut, and all the stakeholders. Thank you to Dr. Suresh Pillai for the excellent lecture, very informative, very inspiring. We all are thankful to you. I think, sir, one more question is there in the chat. Sir, Dr. Suresh, could you please look into that? I'm
I'll check
sorry
that.
Some degradation, or I use something in it.
Let me check that.
Yeah.
So I think already answered, sir. Only 2 questions in the chat box.
Okay.
Now it is posted about the talk.
Fine, perfect. Then that's okay. So it is. I think it triggers a lot of thought in many people, and I'm sure the scholars will also think in that line. I think that many of the students, when I look back to the profiles of any of the students, in fact, they can have extensions to this area from their main domain of research. They can have extensions to this area. So a part of photocatalysis can be added to the thesis somewhere, because many of them are working in nano particles. So I'm sure people contacting him, he's very receptive. So those who want to speak to Dr. Suresh for technical clarifications, technical assistance, and of course for the information for the job prospects and academic prospects in Europe, I'm sure Dr. Suresh would be glad to support you. And I hope that when he said that initially he would be visiting India again in 2021 December. So hopefully we hope that he will find some time to visit us and to have an interaction with the students. So thank you, Dr. Suresh, for the wonderful presence, very inspiring, and thank you for spending a lot of time for us. You took time for the preparations, you took for sitting with us for a load of for a long time, and carefully answering the questions, patiently answering the questions. So thank you. We wish you a wonderful time. So hope Saigo, you are now. you are going for lunch with family now?
Yeah, no, yeah, it's 11 o'clock only now, so I have 2 more
Yeah. Okay.
hours to work, and then yeah.
So our wishes
Okay.
to your research team. Thank you.
Sure.
Because your guidance always.
Sure.
Thank you,
Thank you,
Dr. Sujit.
Doctor.
Thank you very much.
Thank you, Dr. Unikrishnan, and thank you, Dr. Sujit, and thank you all for attending the meeting, and particularly who asked the questions. Thank you very much for contributing. Okay. Thank you. Thank you, Aishwarya, for the comment.
Thank you.
Thank you. So I'm going to sign off now.
Take care.
Okay, bye-bye.
Yeah.
Thank you.
Okay.
Signing off.
Bye.
Signing.
Bye.
Thank you.
Bye.